let's finish up this worksheet. Number 3 says it says it wants us to verify this identity that we've been using, that we just got through using actually. And so, how could we verify this? So it shows that this is true using identities that we already have established. So let's see, how can we come up with this? If I was going to verify this identity, I would choose to start with the more complicated side, and to me this looks a bit more complicated. So I'm going to start here. That's my choice. And what I'm going to do with this is I have learned an identity about the cosine of two angles being added together, and I have also already learned an identity of the cosine of two angles being subtracted. We learned that earlier in this section, and so the sum and difference identity. So let's write that down. The cosine of an angle plus an angle is equal to, remember, you can, if you need to memorize, it's cos cos, sine sine, but the sine is different from what this is. So this is equal to cos cos minus sine sine. Now you don't have to memorize them, but if you do, it makes it easier when you're doing your homework. So this identity, the cosine of x minus y, this is cos cos sine sine, cos cos sine sine, but the sign positive negative gets switched, and so on for the sine of x plus y is sine cosine cosine sine, sine cos cosine, but if it's added, it stays added, or if it's subtracted, it stays subtracted. Anyway, this is the ones that we're going to use. So I'm going to use these in here. So the first substitution I will make is to apply this identity right here and this identity right here. So what we have here is 1/2 times the cosine of x plus y is cosine of x, cosine of y minus the sine of x times the sine of y, plus the cosine of x minus y, which is this right here. That is the cosine of x times the cosine of y plus the sine of x times the sine of y. All right, so this is 1/2 times. Do we have any like terms that can be combined up here? So let's see. I have a cosine of x times the cosine of x and a cosine of x times the cosine of x, and so that's 1 plus 1 makes 2. So we have 2 times the cosine of x, cosine of y. We have a -1 sine x, sine y, and a +1 sine x, sine y. So 1 minus 1 makes 0, so those cancel each other out. These two cancel each other out. So this is what we have. 1/2 times 2 is 1. So this is equal to the cosine of x times the cosine of y, and we made the the right side look like the left side. We verified this identity. That's number 3. Okay, number 4 is nice. Oh, that was number 4. Oh, for heaven's sakes. This is number 4. Number 5. Number 5 is a nice one because it is an application of music. And so this is kind of cool. So let's just read this little paragraph. It says, when certain keys on a piano are struck, a felt-covered hammer strikes 2 strings. If the piano is out of tune, the tones from the 2 strings create a beat, and the sound is sour. If the piano tuner counts 15 beats in 5 seconds, how far apart are the frequencies of the 2 strings? So what they want to do to tune a piano is if you hit 2 strings and you hear a little beat, you're like, that means it's out of tune. And so when you don't hear a beat, it is tuned. And so the beat is created, there's a frequency beat, and the frequency beat is equal to the absolute value of the difference of the 2 frequencies of the chords that you've played. So what they give us in number 5, what they tell us in number 5 is information about the difference of these 2. They say, the beat frequency is what they give us. They say, there's a beat and the sound is sour, so it's 15 beats in 5 seconds. So units of frequency are cycles per second, or hertz, right? So cycles per second. So how many beats How many cycles, how many beats did we hear? We heard 15. For how many seconds did it take? Per 5 seconds. So that's really 3 cycles per second, or 3 hertz. This is what the beat frequency is, and this is also the difference in the 2 frequencies of the chord. So they need to tweak those until the frequencies are less and less difference. And so I don't know that they ever really get it to be 0. Maybe they do sometimes, but certainly less than 3 would be desirable, so it's like pleasing to your ear. Okay, how about 6? This is another music application. It says if one tone is described by this, one tone is described by, and I'm just going to call it Y1, K, equals to K, times the cosine of 524 pi t. And then another one is described by Y is equal to, I'm going to call this Y2, K times the cosine of 508 pi t. Write their sum as a product, okay? That's the first thing. Write Y1 right plus Y2 as a product. Ooh, come on, spell. As a product. Okay, that's the first thing we have to do. And then they say, what is the beat frequency if the notes are sounded together? What is the beat frequency? What is the difference of the individual 2 frequencies? So here we go. Let us take this guy and write it as a product, okay? So here we go. Y1 plus Y2 will be K times the cosine of 524 pi t plus K times the cosine of 508 pi t. So what we're looking at is the sum of 2 cosines, and we have that at the top of our sheet. We have an identity we can use. They don't have this K on them, so what I can do is just factor out that K. So if I factor out the K, I'm looking at the cosine of 524 pi t plus the cosine of 508 pi t. All right, let's use that identity that said if I have the cosine of an angle plus the cosine of another angle, it is equal to, let me come here, 2 times, I also have this K out there, so I want to keep that K in there. So this is K times 2, the cosine of x plus y. Okay, this is x, this 524 pi t, this is x, and this 508 pi t is y. So x plus y is going to be 524 pi t plus 508 pi t divided by 2 times the cosine of x minus y, 524 pi t minus 508 pi t all over 2. All right, this is equal to 2 times k times the cosine. If I add those 2 together and divide it by 2, I got, what did I get? I got 516 pi t. And then if I took 524 minus 508 and divided by 2, I got 8. So it times the cosine of 8 pi t. So first thing they said was for us to do was to write this and this sum as a product. So that's the answer to that. The second thing that they said to do was to find the beat frequency. The beat frequency is the difference of these individual frequencies. Okay, let's think about this. Frequency is the reciprocal of the period, okay? Those are reciprocals. Period and frequency are reciprocals of each other. So let's look at Y1 and say, what is his period? All right, in general, for cosine, period is equal to 2 pi divided by b. So very specifically for this guy, right? This is the b. All right, so the period for the first guy is 2 pi you know what? Let's do this. Let's just skip right to frequency. Frequency is the reciprocal of period. So the frequency is going to be b divided by 2 pi. So let's go for the first guy. What is the first guy's frequency? F1. It's going to be the reciprocal of, it's going to be b divided by 2 pi, or 5, 2, 4 pi, which is the b, divided by 2 pi. And so we can cancel the pi's, and 2 can go into 524, and I did this, and I got, what did I get? 262, 262. And this is cycles per second, or hertz. That's F1. Let's do the same thing for F2. The second frequency is going to be B, which is 508 pi. 508 pi divided by 2 pi. And so that ends up being, the pi's cancel, and 2 goes into 508. Let's see, that is 254, I believe. Yeah, 254. So this is 254 hertz. Okay, what is the beat frequency? It's the absolute value of the difference of these two. So the beat frequency, F sub B, is F1 minus F2, or 262 minus 254, or I got 8 hertz is the beat frequency. Those two tones are 8 hertz apart, and so they want to try to lessen that to make a better sound. All right, that is the end of 4.5.